Hey there, Geometry Jamboree. Today we're going to look at 6.3, proving that quadrilateral is a parallelogram. Every single theorem in here is almost the exact same theorem as in 6.2, just opposite. So instead of starting with a parallelogram, we're starting with a quadrilateral, and we're going to prove things about that it is a parallelogram. For example, 6.8 says, if you have a quadrilateral where opposite sides are congruent, then it is a parallelogram. Okay? Because before we said if it's parallelogram, then opposite sides are congruent. Now we can say the opposite. We're going to go rapid fire. If an angle of a quadrilateral is supplementary to both its consecutive angles, then it is a parallelogram. aka, if these add up to 180 and these add up to 180, it's a parallelogram. Again, opposite as our old theorem. Same as if opposite angles are congruent, these guys, then it is a parallelogram. Okay? So again, same stuff, guys, just different day. Same stuff, different day. If you guys need to pause and write it, go for it. It's also in your book. Okay. For what value of these things, x and y, can EF, GH be a parallelogram? Two ways to go. We know angle E is congruent to angle G, right? That's y and that's x. So we are not going to use that fact. But we know angle E, measure of angle E, plus measure of angle H equals 180, right? Because these add up to 180. So that means 3y minus 2 plus y plus 10 equals 180. 4y, y, plus 8 equals 180. 4y equals 172. And let me use my handy dandy calculator. $43. Y equals 43. Now I can use the same thing over here. Measure of angle F plus measure of angle G equals 180. Well, F is 4x plus 13 plus 12x plus 7 equals 180. So we get 16x plus 20 equals 180. Or I can rewrite this using my fancy math skills. 16x equals 160, subtract 20. So x equals 10 divided by 16. There we go. That's all there is to it, guys. Easy peasy, a lemon McSqueezy. Oh, too far. Remember before when we said about the diagonals? We said that the diagonals, if they bisect each other, if we said if it's a parallelogram, then the diagonals bisect each other. This is saying the opposite. If diagonals bisect each other, then it's a parallelogram. This is the only new one that we haven't seen before. What it says is, if we have a quadrilateral in which we have a set of parallel sides and they are congruent to each other, then it is a parallelogram. Now it's the ones that are congruent are the parallel ones, okay? Have to have two things. Let's try some stuff. Now we have to tell if these are parallelograms based on the given information. This one says that EF It's congruent to GD, and DE is parallel to FG. Is it a parallelogram? I need to review. Looks a lot like this theorem, but remember, parallel lines have to be the ones that are congruent to each other. So, no. The parallel lines must be congruent. Now let's try this guy. B. We know these two angles are congruent. We know these ones are. What do we know about ln? It's congruent to itself. So what do we know about these two triangles? Yeah, they're congruent. So this must be congruent to this. Uh-oh. It's a yes. Because opposite sides are congruent. Because we had to use congruent triangles. We used good old angle side angle. Last one. Two trucks being lifted on a mechanism. They raise from underneath. Will the truck remain parallel to the ground? Explain. I want you guys to figure this one out as homework. Come in tomorrow with your ideas, okay? Think about it. Come in tomorrow with your ideas. I'll make a Jolly Rancher question. And last thing, good review. These are all the things that show that parallelogram or a quadrilateral is parallelogram. Look at, think about, this is a handy dandy chart. We're going to end it early today, guys. Enjoy.